Welcome to another new area of operation research, transportation problem. In this part, we are focusing on the maximization problem. Transportation techniques is not always used in minimization problems, but also this can be used to find the solution for maximization problems as well. In the maximization problem, we have a situation where it's focused on maximization of profitability. Here, first thing is we have to convert the maximization table into a minimization table. How we are going to convert a maximization table into a minimization table? The first thing is we have to identify the highest profit of the table. Then we have to calculate the opportunity cost by deducting all the other profit from the highest profit. Then we have a normal minimization problem. Go depth with this transportation problem. Here we have four destinations D1, D2, D3, D4, and D1 has the demand of 900, D2 has 800, D3 has 500 and D4 has 400. Altogether the total demand is equal to 2600. Whereas to suffice this demand we have three origins O1, O2 and O3. O1 has the supply of 1000, O2 has the supply of 700 and O3 has the supply of 900. Altogether it makes 2600. Since the demand and supply is equal, this makes a balanced transportation problem. First we have to convert it into a minimization table. How to convert it? First we have to identify the highest profit. In this portion, you can see 8 is the highest one. So first we are going to highlight that area. Then from the 8, we are going to deduct the other profits. Now you can see from the 8, I have deduct all the profits. This is the way to identify the opportunity cost. Now from here, we are going to convert this into a minimization table. Now you can see this is our minimization table. We have converted the maximization table into minimization 1. Now the same procedure we should apply. Here you can see when we are deduct the highest profit from the highest profit, the answer comes as 0. Now the normal process applied. Here we have to find the initial table using northwest corner method. How we are going to do it is first we are going to allocate to the first cell, which is the northwest corner cell, that is D1 O1 cell. How much we are going to allocate? Whether we are going to put 1000 or whether we are going to put 900. As I already mentioned you, we have to put 900. Why is it? Because it is the lowest quantity. Then when we are allocating 900 units to D1, what will happen? All the demand requirement is fulfilled. Therefore, no more allocation into this D1 column. However, from the original one, we are left with 100 units. So, that 100 should be allocated to the next northwest corner cell, which is D2O1. When we are allocating that to that particular cell, all the supply from O1 is fulfilled. Therefore, no more supply can be done from the origin 1. or one row is fulfilled. Then we are going to allocate to the next northwest corner cell. Next northwest corner cell is O2, D3. How much we are going to allocate? Whether we are going to allocate the next one is O2, D2 cell. How much we are going to allocate? 700, or are we going to allocate 800? As you can see, I have already allocated 100 from origin 1. Therefore, I only need 700 out of this 800 quantity demanded. As well as O2 can supply 700 units. Therefore, I can put this 700 in order to O2, D2 to fulfill the demand requirement as well as the supply requirement. Then all the demand of D2 is fulfilled and no more allocation for D2 column. As well as the supply from O2 has been fulfilled. Therefore, no more supply is allocated from O2. Therefore, O2 row is fulfilled with this supply. Now, what is the next northwest corner cell? That is O3, D3. How much we are going to allocate? Whether it's 900 or 500. I always say that we have to go for the lowest quantity. Here, the lowest quantity is 500. Therefore, we are going to allocate 500 for this area and the balance 400 is going for O3, D4. Then what will be the balance? Here, we are going to calculate the opportunity cost by multiplying the each quantity with the opportunity cost each cell. Now we can see the total opportunity cost come as rupees 6,700. Now let's see how we are going to optimize this using MODI method. First, in the MODI method, we have to use the V values and U values. Normally, we are assuming that U1 as 0. Then, before allocating the cells and U values and V values, we have to check the degeneracy. Here there are 3 rows as well as 4 columns. Then 3 rows plus 4 columns minus 1 is generates 6. However, we only have 5 occupied cells. Therefore, in order to eliminate the degeneracy, we have to put 0 to either of the unoccupied cells. Here we can put 0 to O1, D3, O1, D4, O2, D1, O2, D3, O2, D4, O3, D1, or O3, D2. Any of the area of the unoccupied cells, we can put this 0. Here I have used O2D3 as occupied cell by using a 0. Then I am going to allocate U values and V values. Here I am assuming that first row is as 0, which means U1 as 0. That is the normal assumption. Then based on that, I will find the V values. I always tell that the penalty cost or the opportunity cost is the summation of U value and V value. If the U1 is 0, to get 2, we have to put V1 as 2. Then V1 plus U1 come as 2. දෙක හැදෙන්නේ U values සලයි V values සලයි දෙකේම එකතුවෙන්. එතකොට V value එක යම් අගයක් වෙන්න ඕනි. මොකද U value එක බිඳුව නිසා. දෙක ධන බිඳුව කියලා කියන්නේ උත්තරේ 2යි. ඒක නිසා අපි assume කරනවා V1 වලගේ 2 වෙන්න ඕනි කියලා. In the next one, if U1 is 0, how we are going to arrive at V2 value? It says same. U1 plus V2 should be 2 to arrive at a value of 2 for D2 O1 set. O1 D2 වලගේ 2 වෙන්න නම් V2 වලට U1 එකතු වුණාම 2 හැදෙන්න ඕන. මෙතන U1 වලගේ බිඳුව නිසා අපි මෙතනට 2ක් එකතු කරොත් විතරයි අපිට 2 ලබා ගන්න පුළුවන්. ඒ කියන්නේ V2 වලගේ 2 වෙන්න ඕනි. Now we have already found the V2 value as 2. Then how we are going to arrive at this 6 in O2 D2? To arrive at 6, we have to add another additional 4. Then 2 plus 4 as 6, which means our U2 value should be equal to 4. Then we have occupied the O2 D3 cell. O2 D3 cell have a value of 4. If U2 value is 4, then V3 value should be 0 to arrive at this value. Then if V3 value is 0, how to arrive at U3? Then U3 value should be 1 because to arrive at 1, we have to add another 1. If U3 value 1, then what will be the value for D4? Then it should be -1. Now based on this northwest corner method, we have found U values and V values. The next step is we have to find the CII value of the unoccupied cells. CII means the cost improved index. Here, these values indicate that how much of transportation we can reduce further. When I substitute the values for CII, I have found that O2 D1 and O3 D2 have the negative values. These values indicate that I can reduce transportation cost further by supplying into these areas. Therefore, in this one, I am going to select the highest negative value. Here, the highest negative value is O2 D1, which means I have to supply into this particular cell to reduce the transportation cost further. Now, let's see how much we have to transport from other location to this unoccupied cells. Here we can transport from either O1 D2, O1 D1 or O2 D2. Then how much is the quantity we should allocate? Out of these particular cells, we have to allocate the lowest quantity, which means we have to allocate 700 units. Then when we are supplying 700 units from D2, O2 to O2 D1, this particular cell will be empty. Then the quantity won't be equalized in the D2 column. Therefore, we have to add another quantity to O1 D2 cell. So, to balance this quantity required by the D2 destination. Then if we are adding more quantity to D2 O1 cell, the balance of the supply from O1 origin will be unequalized. Therefore, we have to reduce another quantity from this O1 D2 to equalize this supply. Then if we are deducting particular quantity from here, what will happen is that the balance will be not happen in the D1 column. Therefore, we have to add another quantity to O2 D1. මේක වෙන්නේ මේකයි දරුවෝ අපිට ගන්න පුළුවන් D1 කියන ලොකේෂන් එකෙන් හරි D2 කියන ලොකේෂන් එකෙන් හරි O2 D1 කියන තැනට. එතකොට ඒ තැන් දෙකෙන් අපි ගන්නකොට මොකද්ද වෙන්නේ? අපි ගන්න ඕනේ තියෙන දෙකෙන් අඩුම අගය. ඒ කියන්නේ අපි ගන්නේ 700යි 900යි දෙකෙන් අඩුම අගය වෙන 700. මේ 700 ගත්තා කියලා විතරක් බෑ. මේ 700 ගත්තොත් මොකද වෙන්නේ? එතනින් මේ 700 අඩු වෙනවා කියලා කියන්නේ මෙන්න මෙතන D2 වලට ඕන 800න් 700ක් අයින් වෙනවා. එතකොට එතන තියෙන්නේ 100ක් විතරයි. එහෙනම් අපිට තව 800 වෙන්න තව 700ක් ඕන. එහෙනම් අපි මොකද්ද කරන්නේ? මේකේ O1 D2 කියන එකට 700ක් අපි එකතු කරනවා. එතෙන්ට 700ක් එකතු වුණොත් මොකද්ද වෙන්නේ? 900යි 800යි වෙනවා. ඒ කියන්නේ අපිට 1700ක් එනවා. 1000ක් නෙමෙයි 1700ක් වැඩිපුර එනවා. එතකොට මේක බැලන්ස් වෙන්නේ නැහැ. එහෙනම් මොකද්ද මම කරන්නේ? එහෙනම් මම කරන්නේ O1 D1 කියන තැනින් අර වැඩිපුර දාපු 700 ගාන අඩු කරනවා. එතනින් අඩු කරලා ආපහු O2 D1 කියන එකට දෙනවා. ඔයාලා මෙහෙම මතක තියාගන්න මේක තමයි ලේසි කෙටිම ක්‍රමය මතක තියාගන්න. කොයි පැත්තට හරි ධන සංඛ්‍යාවක් දැම්මොත් ඒ රෝ එකේ ඒකට සමාන ඍණ සංඛ්‍යාවක් එන්න ඕනේ. ඒ කියන්නේ ධන වලට ඍණ කැපෙන්න ඕනේ. ඒ වගේමයි කොලම් එකකට ගත්තොත් කොහේට හරි ධන ලකුණක් එනව නම් ඒකේන අනිත් පැත්තකට ඍණ ලකුණක් ඇවිල්ලා ධනයි ඍණයි කැපෙන්න ඕනේ. ඒ කියන්නේ නියුට්‍රලයිස් වෙන්න ඕනේ. එහෙම වුණොත් විතරයි ඩිමාන්ඩ් එකයි සප්ලයි එකයි කියන තැන් දෙක සමාන වෙන්නේ. එහෙම වුණොත් කොයි පැත්තකට හරි රෝ එකකට ඩිමාන්ඩ් එකකට ක්වොන්ටිටි එක වැඩි වෙලා එහෙම නැත්නම් කොහේ හරි තැනකට සප්ලයි එකට ක්වොන්ටිටි එක වැඩි වෙලා මේක අන්බැලන්ස් එකක් වෙනවා. එහෙනම් ඒක නැති කරගන්න පුළුවන් එකම ක්‍රමය තමයි කොයි හරි ලොකේෂන් එකකට අපි allocate කරනවා නම් මේක විදිහට O2 D1 වලට allocate කරනවා නම් අනිත් තැන් වලින් ඊට සමාන ප්‍රමාණයක් අඩු වෙන්න ඕනි ඊට සමාන ප්‍රමාණයක් එකතු වෙන්න ඕනි. Now if we are removing 700 from this O2 D2 and if we are adding it to O2 D1, what will happen? You can see the answer like this. O2 D1 will be 700, then O1 D1 will be 200. Since we have already 900, then we are deducting 700. Then O1 D2 will be 800. We have already 100. Then we are going to add another 700. Finally, O2 D2 will be 0 because everything will be taken from this particular location. Now the next step is we have to find the U values and V values for this particular answer. I already mentioned that U value is 0 for the first row. If U value is 0, to arrive at 2, we have to add another 2 for V1. Then, if U1 is 0, to arrive at 2 in O1 D2, we have to add another 2 for V2 cell. Then, as I mentioned earlier, I will occupy this O2 D3 cell because we have to remove the degeneracy. Then when I occupy this cell, I would be able to find the value for U2. How we are finding the value? The O2 D1 has got an answer of 4, whereas V1 is only 2. Then arrive at 4, I need additional 2. This is how this U2 value comes as 2. Then, if this U2 value is 2, arrive at 4, I need another additional 4 in O2 D3 cell. Therefore, V3 would be 2. If V3 is 2, if D3 O3 value should be 1, how to arrive at? O3 D3 වල අගය 1 ඇවිල්ලා තියෙන්නේ. හැබැයි V3 වල අගය අපි කලින් හොයාගත්ත 2යි කියලා. එහෙනම් එක එන්න නම් දෙකෙන් මොකද්ද වෙන්න ඕනි? එකක් අඩු වෙන්න ඕනි. එහෙනම් අපි කියනවා U3 වල අගය වෙන්න ඕනි -1. 2 plus -1 equals 1. ඊළඟට අපි බලමු. එතකොට U3 වල අගය ඍණ 1 වෙන්න නම් මෙතන අගය ඒ කියන්නේ O3 D4 වල අගය බිඳුව වෙන්න නම් මොකද්ද වෙන්න ඕනි? ධන 1ක් එන්න ඕනි. එතකොට ධන 1යි ඍණ 1යි වල අගය එනවා මොකද්ද? බිඳුව කියලා. Then we are going to find the cost improved index of each unoccupied cell. Now when I calculate the figures, I have found all the values are positive. This indicates that I cannot reduce this transport cost further by allocating to any of these unoccupied cells. මේකේ අගේ ධන කියලා කියන්නේ තව දුරටත් අපිට මේකේ transport cost එක අඩු කරගන්න බෑ කියන එක. Now, based on the figures and based on the allocations, I have calculated the opportunity cost. The opportunity cost in this particular allocation is 5,300. That is the lowest opportunity cost. Now, what I have done here is I have transferred the quantities to the original table. Original table is indicated with the profit figures. Original table එකේ අපිට දීලා තිබ්බේ හැම තැනටම හැම සෙල් එකටම profit වල අගයක්. ඒතර මම කරන්නේ කලින් හොයාගත්ත විදියට minimization table එකේ තියෙන quantities ටික, ඒ කියන්නේ අපි optimize කරපු table එකේ තියෙන quantities ටික දානවා මොකටද? මගේ original table එකට. Now, when I have substituted the values to the original table, the next step is I have to calculate the profit. The maximum profit I have undertaken by allocating to this particular allocation is rupees 15,500. එතකොට මම අර තියෙන ටික පරණ විදියට අපි allocate කරොත් මට උපරිම ලාභයක් ලැබිලා තියෙනවා 15,500. මේ විදියට ඔයගොල්ලෝ allocate කරලා පරණ past papers ටික කරලා බලන්න ඔයගොල්ලන්ට කරන්න පුළුවන්ද කියලා minimization problem එකකින් උත්තර හොයනවා වගේම maximization problem එකක් minimize කරලත් උත්තරේ හොයාගන්න. Thank you. I hope that you have gained some knowledge with regard to transportation as well as how we are going to deal with a maximization problem. If you like this video, please put the thumbs up, and if you have gray areas or if you want to make any suggestions, please leave a comment in the comment box. See you with the next video of transportation minimization problem.